Fantastic. So, hello, friends. This is actually a re recording of the session that I did on June 8th, 5 p.m. IST, the webinar on the opportunities and challenges in artificial intelligence. My name is Arun Das. I'm a research fellow at UT San Antonio, currently working in the Secure AI and Autonomy Laboratory and Open Cloud Institute. I'm doing this as a separate video right now because there were some technical difficulties in actually gathering the recorded stream. I posted in my social media that I was exporting this webinar, and unfortunately I lost it because of some issues. So I'm re-recording it, and hopefully this time I can actually mention some points that I actually missed and add some stuff that I think will enhance the experience of this webinar. I'll try to skip through some of the slides which I emphasize a little too much. I got so much feedback from the people who were actually able to attend the webinar. So let's get into it. So the age of artificial intelligence, we hear this buzzword quite a lot. We read this particular keywords in our newspapers. When we scroll through news feeds in our phone, our social media, everywhere we hear this term artificial intelligence, deep learning, machine learning. Several other terms which we kind of understand in a very high level, but we don't or we might not quite understand to the very detail. So we'll try to do justice in this talk, and we'll try to define some of these terms for you, so it'll be a little bit more easier for us to segregate the different levels of these particular terms. We see that Microsoft introduced AI into their speech platforms to improve voice translation. We see that Uber is actually using AI for their self-driving cars. Tesla is actually using AI for their self-driving cars. We see numerous courses as part of curriculums, AI being integrated into the curriculum itself, even in India. Quite a lot of research is happening in the IITs and NITs and several other institutions across India. Um, we have our phones, mobile phones, and we have Google now, or our Google Assistant or Apple Siri. We just have to call for them, and they can give us results which we don't have to now type with our keyboards or with our fingers. So this is a very interesting time to be in, actually, because we see quite a lot of change happening in this dynamic environment that we have. We see that almost 40% of all the tech organizations now have some form of AI in their pipeline. So it can be some form of AI where we might be using it for some kind of data analytics. We might be using it to understand the customers better. We might be using it for marketing. In a variety of places, we use AI in our day-to-day life. Towards the end of the webinar, we will go through some slides where we'll see some of the interesting use cases that we as humans might not even care, or you um, we might not be even understanding that we use AI in our day-to-day life. We will discuss some of those examples. But before getting too ahead of ourselves, I will show you one slide with a bunch of images which describes or which summarizes some of the different researches that we do in our lab. So in this slide with a lot of images, the one on the top left that you can see here on the top left, That is a work that I've done with some researchers from some ophthalmologists from California, and my professor. This was a neural network that we built to understand the severity of age-related macular degeneration. That is a disease which affects the retina of your eye. So this AI was able to get an image of the eye and tell what kind of severity of AMD is present in this eye. The one that you can see on the right side, this is a work with I did with one of my colleagues. Here we input MP3 music. We convert the MP3 music into a MEL spectrogram, a power spectrogram, and then we use a deep neural network, an AI model, to train to understand what genre of music that particular MP3 file has, and what kind of instruments are actually used in that MP3 music. So that was a very fun kind of AI project that we did. The figure that you see on the lower left is a work done by one of my colleagues. This is more towards understanding how we can use AI for action detection and intensity indexing. For example, if you are punching someone, you will be punching, you might punch playfully, joyfully at one of your friends or something, or you can really hit one person if you want to hit him. So um, on top of understanding what action is being done on a video scene, this AI can actually tell you the intensity of that action. So whether it is a mild punch or a very hard punch. The one that you see in the middle, this is a deep learning model that is used to track individuals over multiple frames or video, and this is done using drones. This is a project that was done by one of my colleagues as well. The figure that you see on the bottom right, this is applying AI to financial domain, where we try to understand how maybe for example how the market is changing, and use an AI to estimate the changes and predict how the market might change in the future. So as you can see, we have like a plethora of different applications that we tackle within our small subgroup. So the point here is that AI is a very interdisciplinary field where you can apply these kind of techniques to a variety of problems. I was talking to one of my cousins today morning, and I was telling him how we can create an AI to understand what card or Pokemon card, or what kind of Pokemon character is in a particular image. So I'm going to work with him to build an AI to detect Pokemon cards, hopefully. So uh, that's how dynamic AI is, and that's how easily, or that's how easily available AI is right now. So let's talk about some of these taxonomies and try to understand how we can kind of combine a lot of this information and kind of segregate some of this, so we understand it properly. There are two main books that I follow. Both of these I'm reading. I actually read the deep learning book. This book that you see on the right is called Deep Learning, and it's by three very good authors: Ian Goodfellow, Yoshua Bengio, and Dr. Aaron. Um, this book basically gives you quite a lot of information about what deep learning is, how deep learning works, and what are the many different techniques that you can use in deep learning. I got the figure that you see on the right side from this book. I've referred um, the book below the figure. The book that you see on the left, Thinking Fast and Slow by Daniel Kahneman, that book is a particularly interesting one because it introduces the notion of system 1 and system 2 way of thinking. That is the way how, as humans, we think, as humans with cognitive abilities, how we think while we are making some kind of decisions. So system one basically relates more towards those kind of actions that we do unconsciously. So if you see something and you understand that that particular something is that thing that you have in your mind. For example, you see a pen and you immediately know that it's a pen. You don't have to do a lot of processing in your head. So those kind of thinking which happens very fast and almost automatically, those kind of those kind of thinking is called system one kind of thinking. Whenever you want to make some kind of complex decisions on top of it, that is where system 2 comes into place. For example, if you want to multiply 23 and 54, you have to use some other part of your brain to include some other kind of logic into this decision making now. So that is where system 2 comes into play. You have to take your time, think slowly, build upon some of these decisions that you are making. So that is where system 2 comes into place. And whenever you have some very quick actions or some very quick thoughts that you can process, that is where system 1 comes into place. The figure that you see on the right side, the AI is on the outermost circle. So machine learning comes inside it, representation comes inside machine learning, and deep learning is a form of representation learning that comes inside representation learning. So this kind of an architecture, so to say, or like a hierarchy, this is what we will be expanding in the coming slides. So just know that artificial intelligence or AI is this broader topic where we have machine learning, representation learning, and deep learning within AI itself. So if someone asks us to define what is AI, we, it's a little tricky to actually understand each of these and kind of have a difference between these different taxonomies. So in a very high level, wherever we can receive, process, and manipulate high level concepts to make some kind of complex and logical decisions, that is where we can apply AI. So that basically means that you have a bunch of data, you have the knowledge that you can do something to this data to generate something else, and you want to do it autonomically without the use of human input. That is where you can think about creating an AI algorithm to automate it for you. Say, for example, you have a lot of bank checks coming in. You want to read individual, numbers returning these checks, and read these checks and do some other process after it. You probably can think about replacing this manual job of reading checks by using an AI. And we see that, if you read some kind of AI literature, you see that these kind of manual jobs were already replaced by AIs many, many, many years back. In fact, I've had chats with engineers from several companies, um, where one interesting thought that we shared with one engineer was that he was working for a printer company, and he was using some form of AI logic to improve the efficiency of printer cartridges in dot matrix printers. So the old school printers, they were using some form of AI logic to know where to put dots for specific alphabets. So it's a very interesting interesting field, definitely. So what we can do right now is to solidify our knowledge on these fields by using or by defining some of these taxonomies. So let's go to next slide to do that. So the goal of artificial intelligence that you see on the outer circle is to receive, process, and manipulate high level concepts, and to make complex and logical decisions automatically in a dynamic environment. So what that means is that you receive some data, you process it, you manipulate it, you try to understand some kind of high level concepts in this data, and you make some kind of logical decision based on that data. And this can be all happening in a dynamic environment, where many different decisions needs to be done. Say for example, if you are thinking about a self-driving car, you are driving your car in a very dynamic environment. You have very less understanding about what is going to happen next. There might be different cars or bikes or whatever coming into your way. So in this kind of a dynamic environment, the role of the AI is to receive some information. Say for example, a camera sensors, a camera is looking at the road, and that camera feed is coming to the AI. You process that data, you try to understand some kind of high level concepts from it and make some kind of decision. Say for example, if there is a stop sign coming, the AI will be able to tell the self-driving car, hey, a stop sign is coming, you might want to slow it down, slow your car down, something like that. So the goal of AI is to actually receive all of this information, process all of this information, and then do a particular task. So that is it. So that is the high level information. Please note that I am trying to dial it down so much to share this with a larger audience, especially undergrad students who have little to no experience in AI. So please bear with me on this. So the next level that we see is machine learning. It is an application of AI that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed. So take a second to read it and see if you actually understand it. So machine learning is basically a subsection of AI, or it's basically an AI learning algorithm where it tries to learn automatically from this data without explicitly programmed to do so. There are no if then loops here in machine learning. We are not saying if the distance between the car and the stop sign is this much, do this. No, we don't do that. Instead, we throw a bunch of data to the machine learning algorithm, and the machine learning algorithm tries to find correlations between the data and tries to understand when to stop the car or when to slow down the car. It is doing it automatically. That is the main difference between the logical if then loops and machine learning. Machine actually learns to do something from the data. So that is where machine learning comes into play. Whenever we have a case where we can condense this high level knowledge to some form of some very dense representations, that is where the representation learning comes into play. If you don't understand this completely, don't worry, we will in the coming sessions we can actually go very deep into it. But wherever you can actually convert, say for example an image, you have a photograph of something, you want to convert that photograph into a vector of information. So for example, if you have a 28 by 28 image, you want to convert into a 100 length vector, you try to condense that knowledge somehow. I'm not going deep into the architecture of all of this, but there is a process in the middle which can represent this higher dimensional data to a smaller dimensional or lower dimensional subspace. That is where the representation learning comes into place. Deep learning that you see in the innermost circle is one of the primary reasons why I am having this talk with you, because deep learning is one of the ways of representation learning where the deep learning algorithm is based off layers and layers of neural networks, which actually tries to mimic our neuronal activities in our brain. So wherever you have a neural network based learning algorithm which tries to understand high level data and condense that knowledge into low level representations, you can call it as a deep learning algorithm. The deep in that deep learning basically means that you have many layers of neural networks. So if you have 10 or 100 or even 1,000 layers of neural network, You can call it as a deep neural network. There is no minimum number that you need to fix to call it deep learning. People call 6 layer, 10 layer, whatever layer networks as deep neural networks, but usually don't call 1 or 2 layers network as a deep neural. That might be another, whatever else. So deep learning is actually a form of representation learning where you use neural networks to learn very complex structures within the data. So unlike machine learning, you try to understand all of the feature dimensions of the data that you have automatically using deep learning. In machine learning, in some cases, you hand pick some of the features that the learning algorithm can make use of. So, for example, if you have house prices to predict based on the number of rooms, the total area of square feet, etc., of a house, the machine learning algorithm might not require a lot of data about how many parking spots are there, or um, how many neighbors you have, etc. That might not be interesting for a lot of people, but that might be a feature for some people. So humans might pick some of these features based on the requirement that the machine learning algorithm has, or based on how accurate the machine learning model finally comes into be. So in deep learning, you don't pick features, so to say. You throw the entire data at it in a very high level. You use as much data as possible, and the deep neural network, the different layers of the neural network, tries to condense all of these complex domains together, and it creates some form of representation, and we use this representation to do, to say whether this data is this class, or this data is doing this, or whatever, whether there is a stop sign ahead, or many different cases. So we will define some of these cases in the few coming slides, so that is why I'm not specifying some of these terms, but let's move on. So we see that AI revolution actually started in the 1950s. I think in 1956 was the date when this particular term was actually used in conferences. Um, Machine learning actually started around the 80s. The examples that I mentioned about the printer, and also email spam detection, reading from images of checks, etc. It actually started in the 80s, excuse me, and also moved into the 90s. There was something called an AI winter, where not a lot of progress was happening in the field of AI. However, as we will see in uh, the 10th slide of this presentation, uh, there is huge interest in the field of AI, mainly using deep learning algorithms that you see, after 2010, you see that there is a huge boom in the deep learning algorithm. This is a picture that I got from NVIDIA's blog. The link is actually cited below the image. This raises a question about where reinforcement learning fit in, and what is reinforcement learning. So let's look into that. So this is where we define some of these taxonomies for the different things that you can do with AI. So wherever you have two different very separate categories, for example, you can see a very cute dog and a cute cat. Wherever you have two different classes of data, you can use AI in a supervised way and train the AI to understand the differences between these two classes. So that first category that you see is called supervised learning, where you want to understand cat versus dog. You use a supervised learning algorithm because you have labels for your individual data points. You have labels for cat. You have a cat image and you know that it's a cat. You have a dog image and you know that it's a dog. So you have labels for cat and dog. Your cat label can be 0, your dog label can be 1, and you have thousands of images of your cat and you have thousands of images of your dog. And this supervised learning algorithm now can go and optimize the parameters of this neural network, so that given a new image of a cat, it can say correctly, accurately, that that particular input is a cat itself. So if you give an image of the dog, that AI algorithm will say that that particular image is a dog. So wherever you have labels in your data set, you can actually use supervised learning algorithms. If you have quite a lot of data and you don't have labels for this data, what you can do is to somehow cluster these data based on several different algorithms. The core algorithm, I'm not discussing it right now, but you can cluster this data and cluster one chunk as cats and cluster another chunk as dogs. This is where the unsupervised way of learning comes into play. So unsupervised learning is wherever you have a bunch of data and you extract patterns and features from this large amount of unlabeled data and tries to cluster them into smaller groups. So you have a group of images called cats and you have a group of images called dog right now. Reinforcement learning is totally different from the supervised learning or the unsupervised learning algorithms you have. In reinforcement learning, you have an environment where an agent, for example in this case a mouse, have specific move to move in this environment. Those movements are called actions. So an agent is in an environment and that particular agent have specific actions to do, and the goal of the agent is to fulfill a particular task. So you can see in this image that there is cheese in this on the upper left side, and the goal of this particular agent is to move from that initial starting position and go get that particular cheese. That cheese can be called as a reward. Whenever you take that cheese, you will get say 10 points or something, and if you fail to get the cheese in a specified amount of time, you get minus 10 points. So what the agent do when it when the agent is trained on this environment, that's the word we use, trained. So when the agent is trained on this environment over and over and over again, millions of time, maybe billions of time, that agent has a memory, and in that internal state the agent actually learns how to map in this environment to get higher and higher reward. So what you get after training your agent for so many iterations, so I'm actually introducing some of these words right now. Iteration is when the agent completes one cycle. So whenever the agent completes these cycles, millions and millions of times, the agent learns the internal states, or the agent tunes its internal states so that it gets better and better rewards. So in effect, the agent is actually learning the environment and learning to navigate in the environment. This is a very high level. Some of my colleagues might laugh hearing me explain it this way, but just know that there is an environment and an agent, and the agent is trying to optimize its path and doing something so that the reward is always getting increased. Okay, so a classification problem, as we mentioned in the previous slide, is where we have two or many different specific categories. Say for example, we have a cat here and a dog here, so we know that there are two classes, so we are doing a classification problem. In a regression problem, we have a bunch of features. Say for example, we have house prices on the y-axis and squared feet on the x-axis, and the green dots that you see are the price for particular square feet. So a regression problem might be to understand how much in a number value, uh, what is the output in a number value. So given the squared feet, what is the house price. So we regress, or we generate a particular, or calculate a particular value in this problem. So that is where we have regression problems. Say my self-driving car is actually moving at 10 miles per hour, or 10 kilometers per hour, and um, the traction of the road is this much. I have a car 20 meters in front of me. Quite a lot of variables that comes in, and you are trying to understand what will be my speed in the next second, or next 3 seconds, or whatnot. So there you are trying to understand one value, or trying to calculate one value instead of segregating between classes. That is where the regression problem comes into play. So what can be my attendance for my next session if I create an AI based on the number of students that showed up for the first webinar, and the number of questions that were asked for the first webinar, and the number of responses that I gave, the number of people who found me in LinkedIn. If I take all of these variables out, and if I train an AI, and if I try to understand one number, how many participants will be there in my next webinar, that is a regression problem. Okay. So all right, so let's move on. There are so many areas of focus for AI algorithms. I am noting here 4 of the main ones. The reason why I choose these 4 is because I primarily have experience with these. There are quite a lot more, but let's focus on these 4, so we actually kind of understand what's going to or what is actually happening in a very high level. So the first field that I want to talk about is computer vision. This is something that I work primarily. Excuse me. So the figure that you see on the right side, that is where we apply computer vision on something called semantic segmentation, where you are trying to segment this image, individual pixels of this image, as a particular class. So you can see different colors in this image. The road is kind of a purplish color, the sidewalks are pink, humans are red, cars are blue, the tram is some other color. All the signs that you see are yellow in color. So we are trying to separate individual layers in this one figure that we have, or one image that we have. We are segmenting it out as different objects in this image. Excuse me. So that is where um, we can actually use computer vision, or the example that I showed in the first few slides, where I took the image of the retina, micro a retinal frontal image, and you use that image to understand whether there is a particular disease in that image. Cases like that, where we use image as an input, you can throw it as into this class, where we can call it as computer vision based projects. Wherever you have some form of text or natural language involved, you can call it as an NLP, or natural language processing based project. You can see below on lower left, um, if you search something on Google, uh, or if you try to translate something, or from one language to another language, if you use Google Translate or something, the entire thing that happens behind the scene is actually using natural language processing algorithms. So NLP is actually used for quite a lot of things, other than just translations or transcriptions or etc. This field is very important and very hot right now, so you might be interested in looking at it. Robotics and intelligent control using reinforcement learning based systems. This humanoid robot that you see is actually being trained in an environment like we saw on the previous slide. there was an environment. The mouse was the agent in that environment, and the goal was to get the cheese. Um, Here, the goal is for a stick figure to run like a human. So, this humanoid stick figure is actually trained in an environment to behave like a human, or run like, or move like a human. So what happens is that, if you Google for it, or if you search in YouTube, you'll see a lot of these videos where people are training reinforcement learning algorithms or agents to do some task that we do as humans, in like walking or whatever. You will see that these stick figures actually start from just laying down, or just random actions, and after millions and millions of iterations, these figures start to do that process properly. um, it's a very interesting field, and very exciting field to be in, mainly because of the robotic element to it. Um, you can Google for a company called Boston Dynamics. They are very advanced when it comes to robotics using RL. It's a very interesting and quite scary, to be honest. Demos that you can see in YouTube. Just search for that particular name, and you will definitely get it. Boston Dynamics. So AI is also used quite a lot in speech and language processing, where you speak something and you maybe get a text transcription of it. So wherever there is speech and language involved, even some of the audio based projects that I shared previously, you can think of AI as a way to actually use a lot of these uh, speech information. When you say okay Google to your Google phone, or hey Siri to your Google phone, that level of understanding is happening in there. Whenever you speak to your Google keyboard when you're lazy, that transcription of your voice to text is happening using AI algorithms, which are actually in your mobile phone itself. It's not a cloud service, it's actually in your mobile phone. So AI is actually, for me, these four fields are quite interesting, and AI is actually very important in driving research in these four fields. So let's see what is actually driving the AI revolution right now. So these are my personal opinion, and these are actually passed on to me as high level ideas by my professor and my mentors. So the three main vectors of AI is actually cloud computing, big data, and AI accelerator chips. Cloud computing, where right now, some of you might already know about Google Colab, where you have a cloud-based web service where you can go access and run your code, train your AI algorithms, etc. If you don't know it already, cloud computing is basically like having access to a very high compute in a server, um, which you can directly log in from your laptop, and you can decommission that server whenever you don't want it. So it's like borrowing a laptop from your friend and using it and giving it back whenever you are done. Just that you have to pay some money for it. So what cloud computing enables is that it's easily available right now. Amazon Web Services, Microsoft Azure, and Google Cloud. You can get virtual machines from them for very little amount of very little money. I'm sorry, very little money. So you can perhaps lease one of these cloud computing nodes for 2 or 3 days, and it won't be an enormous amount of money like you will invest in a server. So that is one of the main drivers of AI revolution. Cloud computing also enable people to share their research properly and um, have kind of a scalable architecture to train multiple machine learning models in multiple machines, or the same learning model which doesn't fit in one machine, now you can train on multiple machines and scale it up and scale it down when you are done. So you don't have to set up hundreds of servers in your lab. Instead, you can lease hundreds of virtual machines for 10 hours or 3 days or whatnot, and then now you can release them when you are done. So that is the scalability that you get from cloud computing. Big data, as you already know, you have all of you have heard this term. We do around 40,000 Google search queries every second, and we have around 300 hours of YouTube video uploaded to YouTube every minute, and we have around 27 billion IoT devices, Internet of Things devices connected um, in 2019, transferring data between the source and the destination. So big data can actually generate tons and tons of data. Petabytes of information can fill up storages in a matter of time. So the huge amount of data that we have, and that data that we have access to train these deep neural networks, which have layers and layers of parameters, we need huge amount of data. So the enablement of big data and the use of cloud computing to actually host this big data, have scalable compute, have huge amount of storage options, that was one vector which drove the AI revolution. AI accelerators, which is fundamental in training deep neural networks, uh, it's actually one of the things that was improved quite a lot by using NVIDIA based GPUs using CUDA development engines. Machine learning researchers saw that you can parallelize the machine learning operations or the deep learning, individual mathematical operations happening within these neural networks. You can parallelize them in these parallel cores of graphical processing units. So instead of doing it serially in a computer like a CPU based system, you can now parallelize your matrix multiplication, say, in this thousands of small individual cores of a GPU. So once you do that, once you scatter your data to this GPU cores, you do the compute there and you gather the answers back. You do some light processing in those answers and you use those answers. You can perhaps cut down the time 10 times or 100 times if versus if you are just using it on a CPU. So AI accelerators actually improve the training time of deep neural networks by a huge margin. Now we have specialized GPUs just for deep learning, specialized TPUs, that is tensor processing units, that's developed by Google for their neural networks, and field programmable gate arrays, FPGAs, which have specific architecture for specific machine learning workloads. So all three of these combined, cloud computing, big data, and AI accelerated combined, we have the power to actually drive the AI revolution forward. Now, if you look at individual of these vectors that I've listed here, and if you Google search for individual of them and try to understand the relationship to AI, I'm pretty sure you will be amazed by how much influence each of these have to AI. Okay. Let's see now where we are with AI. So we talked about what different areas of AI are. We had computer vision, natural language processing, robotics, and speech and language processing, etc. We saw what supervised learning algorithms are, unsupervised learning algorithms are. We went through the taxonomies, what is AI, deep learning, machine learning, representation learning, all of this stuff. Let's see where we are with AI right now. Here, I have a small subhead. This is a question that I get quite a lot. So one thing that we can do to make it easy for me to describe how impactful AI is right now, excuse me, is to actually go to this website. Let me try to do that right now. Okay, so this image that you see here, this is actually generated by an AI algorithm, and this is not a real person. Okay. For me, this is quite interesting and scary at the same time, because the precision by which the AI generates these faces, these figures, these people who doesn't exist is quite scary. Right? If I right click reload, the image that you see here, it is completely generated by AI, and the details you can see here, it's using a method called generative adversarial network. Um, and it's the model's name is Tilegan 2. So you can see here, the it's quite scary, because you can now think about scenarios where people can just fake images, and you can have scenarios where um, you know a lot of felony can happen just because you have the power to generate these faces now. Right, I'm just reloading for one more time. So these individuals that you see here, uh, they are all generated by AI algorithms. That's quite interesting, actually. There are actually other images as well. This is an image of a cat that was generated. This is another image of a cat. But in these images, you can see, like, the right hand side, there are some issues with the generation. But those human faces, that's where people actually put quite a lot of focus on. That's quite scary. At least for me, it's very scary. So one of the reasons why it is scary is that now people can fake um, other, and make basically false accusations. There is something called deep fake, where you can generate videos based on these fake images that you have right now. Say, for example, I'm speaking to you, and my face can be replaced by someone else's that is AI generated, and have the same facial expressions that you see on my face right now. So that is scary. Now someone can actually do like threatening video or something, or say something really bad about something or someone or some country or whatever, and now that can lead to very huge consequences. So that is the reason why I'm scared. Okay. On a less scary note, we have this website. I'll go to this. So in this website, this is a speech to text application, an AI based application shared by Microsoft Azure. So if I press on this button speak, anything that I speak after I press the button will be converted into text. See, that is how real time and easy it is to convert my speech to text. So these are all AI based, real time applications which you can use in your software right now, in your software pipeline right now. So this is highly interesting and amazing for me to see, because I have been through this stage where we have developed several algorithms, and this won't work on real time. And this is real time on good hardware, and these kind of applications are actually running in a website with the latency of the internet and all that stuff. My sound has to do, this AI has to do some processing on my sound, and then have to produce the results, show it in the website, etc. So this is amazing. Think about how much mm, of an impact it can have for quite a lot of fields of science. One of my friends, who is actually interested in filmmaking, he was asking me whether there are any AI algorithms which can do automatic speech to text based on specific languages. For my case, it was Malayalam. So he asked me whether there is a way to convert Malayalam to text automatically. I told him there is a way to do English to text automatically, but unfortunately Malayalam to text is not there now. And unfortunately I don't work on this field of NLP or speech translation, etc. So I was not able to answer him properly, but I'm pretty sure Microsoft or some other companies are on it already. Okay, so the key takeaway from this is that AI can do some tasks really well, and we are confident enough to use some of these algorithms in our day-to-day life already. So this is where my research kind of comes into play, and this is in trying to understand why this AI is trying making a particular decision. Say, for example, a traditional machine learning pipeline is what you see here on the top, where you have a bunch of data sets. You do some data analysis on this data set. You try to train and optimize your deep learning models, and once you get a good performance on a testing set, you will say, "Hey, good job, you have good accuracy, very good." But for a doctor, an ophthalmologist, someone who takes an image of a retina to understand what disease category it is, what severity of AMD is in this particular retinal image, we cannot just say retina, this particular retinal image is a normal image, or there is no AMD or whatnot. We have to explain why this particular decision is true, why this particular decision makes sense, etc. So for example, you have to explain separate features in the input domain or metadata that you can generate in addition to the output, to explain why the AI is making particular decision, how the AI is making that decision, etc. So my research is in explaining the decision of highly nonlinear deep neural networks, and this field is generally called explainable artificial intelligence, or XAI in short. So that is my field of PhD actually right now. So you can see three different images on the slide. The one that you see on the left is called it's from a paper called LIME, Local Interpretable Model Agnostic Explanation. You don't have to worry too much about the name and the algorithm, etc. Just wanted to show you guys how an explanation can make sense to to explain why an AI made a particular decision. So this image, when you gave it to the AI algorithm, it said that there is a 54% chance that this image is a frog. And you ask the explainable algorithm why this is a 54% chance, and the algorithm generates an explanation and says, hey, this patch of image made it to be 54% prediction. So now we can view this image and we say, oh yeah, there is a face of a frog and some of the features of the face. So now perhaps that is a frog itself. So we can have some kind of an understanding like that. The image on the right that you see is from a paper called Shapley Explanation. It's called SHAP in short. And here what we are trying to do is to create um, some kind of feature correlation or feature importance for a particular decision. So say for example, if you look on the image on the row number 2, the label is a meerkat, and if you ask the deep learning algorithm, sorry, the explainable algorithm SHAP, why this is a meerkat, it will generate an image such as this, and there will be some kind of high intensity red kind of points, red color points on the specific features where that particular algorithm, the SHAP algorithm, thought that it relates towards that particular output. So now SHAP is saying that meerkat, the head region of this image, is correlating towards that particular output. So it predicted that way. So in mongoose, we can see the on column 3 on row 2. Mongoose, we can see a small amount of blue color on the facial region of this animal, and that particular blue color position means that that region decreased the class probability, or it didn't help in improving that prediction. Don't worry if you don't understand this. If you really want to talk about it, you can find me in LinkedIn or send me an email. The main reason, or one of the reasons why I am interested in artificial intelligence or explainable artificial intelligence, is because of the medical applications that I'm working on. And the next one is actually this that you see below. Here, an image of a panda with 57.7 percentage confidence. If you multiply or if you add pixels, some random pixel perturbations to this input image that you have, you can fool a very well performing AI algorithm to predict otherwise. Say, for example, you have a 57 percentage panda classifier, or accurate classifier right now for this particular image, and now you can add some noise, some gibberish to this image, and now the image looks just like a panda for us humans, but for the neural network that we have trained, it tells that the image is a gibbon, and it tells that there is a 99.3 percentage confidence. So that means our 57 percentage panda image now generates a label as gibbon, and it does that for 99 percentage. This is particularly scary, because people have shown in research papers that you can put stickers, randomly shaped stickers, not randomly, they generate these stickers for them. Sorry. I'm sorry, that was a work message. Okay, so where were we? Okay, yeah. So we have published research showing that specifically designed stickers that we can stick on objects can actually fool self-driving car classifiers, where they try to understand stop signs. So imagine you are traveling in your self-driving car 50 miles 50 kilometers per an hour, and now you see a stop sign, and someone actually stuck a sticker on it with a particular shape, and now your car cannot identify that it is a stop sign. It's identifying it as a tree or something, and you semantically segmented your road, and now you can see the road, but that unfortunately that stop sign you cannot make sense of it. So in that case is where this problem actually shows up quite a lot. This one is called adversarial example, in the image that you show on the bottom row. And quite a lot of significant research was done on this field by Ian Goodfellow. If you remember the deep learning book, the two books that we mentioned, the deep learning book, Ian is actually one of the authors of that book. Okay, so one other question, since we are focused on this talk is for electrical engineering crowd. So this question, but Arun, where do we apply AI in EEE, electrical engineering? So I am not planning to focus too much on this, because this is a very high level discussion on the opportunities and some of the challenges of AI. But please note that there are quite a lot of research that is happening in the field of electrical engineering and AI combined. Excuse me. We see here machine learning based estimation of energy consumption. Quite a lot of research in the smart grid area, where we have AI algorithms trying to understand attacks on the smart grids, and some kind of mitigation algorithms. uh, quite a lot of interest in trying to understand demand supply trade-off and that whole kind of paradigm using AI. This is where reinforcement learning comes into play. Just think about a scenario where you have an environment like you have in Simulink, your simulations. Now think about a scenario where you have an environment with huge amount of microgrids connected together to form a smart grid, and your agent might be uh, uh, responsible to um, facilitate the demand supply response, or do some kind of um, you know maybe to facilitate energy trade or something. I'm just thinking about ideas right now at this point. But imagine a scenario where you can actually develop a smart grid ecosystem as a reinforcement learning environment, and you have several agents to do several specific tasks, and the reward might be that this system never goes to blackout, or the voltage level should be in this particular range, the current level should be in this range, etc. So I don't know. I'm just thinking about it and making stuff up at this point, but I'm saying all of these are being done, and all of these are very um, accessible and applicable forms of problems or applications in the field of EEE right now. So another question that I get is that as an undergrad student, how can I break into AI and where do I start? So there are three main things that you should focus on. One is your mathematical background, another one is your programming background, and you should have definitely a system background or a signals and system background. Especially since we are electrical engineers, we should have core mathematical background and signals and systems background, because we should have some kind of control theory, network theory, digital signal processing, digital image processing, these kind of understanding. And from the mathematics side of things, you should have linear algebra, statistics, probability, vector calculus, etc. And in the programming background, as engineers, as electrical engineers, what we are introduced to is MATLAB. MATLAB is a good platform for a lot of work, but we see that significant research is actually moving towards and other programming languages and programming paradigms. So we can discuss that in we will actually discuss that in slide 18, what all programming languages, etc., are being used. But for starters, I went to QSAT website and I searched for QSAT triple E syllabus, and I found the following courses that I think will be interesting if you can spend a little bit more time focusing on these particular courses. So from S3, semester 3, we have linear algebra and transform techniques. We have circuits and networks. From S4, semester 4, we have complex variables and partial differential equations, so circuit signals and systems. S5, we have numericals and statistical methods. S6, we have DIP, digital image processing and control system 1. And in S7, we have control system 2. And if your focus is on power systems, you definitely have to understand power system. But I'm saying generally, if you want to understand AI, say reinforcement learning or some form of computer vision, NLP, etc., and if you want to apply it specifically to electrical engineering based, core triple E based domains, I think all of these will make sense to you. Okay, I will share some online courses for you guys to get started. This 8-week course on machine learning from National Program on Technology Enhanced Learning, NPTEL, is a fantastic source of a lot of information on how to get started on machine learning and what machine learning is, what are the different facets of machine learning. You can then go to a very focused and um, comprehensive course on linear algebra by MIT. Um, this might take some time because they cover quite a lot of linear algebra. But if you just want to refresh your memory You can go to the third link. It's a bite-sized pieces. It's from Michael Van Bizen. You can go there. It's very good. You will get bite-sized pieces of linear algebra in each of his videos. I would like to inspire you to do more deep learning research, search, whatever. Please look at this introduction to deep learning video from MIT, and also the deep learning state of the art by Lex Friedman of MIT. These are two wonderful videos that I think will enhance your understanding about what deep learning is and where we are at with deep learning, especially deep learning algorithms. Some more videos for you for the electrical engineering side of you. There is one video from NVIDIA where they discuss a collaboration with another company where they use AI algorithms to save energy. There is a video from Jim Gao from Google DeepMind where he give a presentation on how AI can change the energy world. Duke University's energy initiative shared one video and they mention about energy data analytics. There is a lot of interest in time series forecasting in the energy sector, and you can look at that YouTube video from Stefano Casau to understand how people are approaching time series forecasting using AI. Say, for example, if you want to understand how much your wind turbine can generate based on historical data, now you can think about it as a time series forecasting problem, and you can use AI to do that. This particular talk is very interesting, but you might hear quite a lot of terms that you don't understand right now, but please Google for them if you want to know more about them, and you can always come to me. I'll be more than happy to actually share my knowledge as well. The last one is the advances in energy efficiency through cloud and machine learning. This is a fun and interesting one to watch. And cloud and machine learning, two things that we discussed previously. Um, the smart grid way of doing things. Smart grid is actually enabled, like two of the enablers of smart grid is actually cloud computing and machine learning. Without cloud computing, you cannot manage quite a lot of these elements together, especially in the data analysis, data processing, data munging, those kind of stuff, and machine learning to generate some kind of predictive algorithms for your smart grids. So do watch this video, get inspired by it. Okay, so let's go back to where we discussed about programming languages. The main programming language that I use personally is Python, the one that you can see here. There is quite a lot of interest in using R in the statistical domain. R is actually used by a lot of statisticians, and I put C++ here because C++ is actually used quite a lot for inference side of things. So you train a machine learning model. Now you want to we call it serving. Now you want to serve that model in, say, an embedded device. You want to run it in NVIDIA Jetson, NVIDIA Nano, something. Now you need to use a C++ API to make it as fast as possible. So C++ is also there. I haven't included MATLAB here because I will be not talking, I won't be talking about it personally. So the layer that you see on top, TensorFlow, PyTorch, and scikit-learn, those are three machine learning platforms that we use, or machine learning packages that we use. So instead of building, say, the individual layers of the neural network from scratch, we will be using TensorFlow, PyTorch, and scikit-learn for, they will do it for us. So we will define, hey, first layer needs this parameters. Second layer needs this, and then TensorFlow or PyTorch or scikit-learn can actually do that for us. The third layer that you see below Python, or that programming languages, that is the different packages that we will be introduced to in the following sessions that we will have. So you can see OpenCV, which is image processing library. Anything I would say almost everything that you learn in your digital image processing class, you can probably do it with OpenCV. Pandas is a library which can be used for a lot of data analysis. So a lot of data scientists actually use pandas to do data analysis. NumPy is a numerical computation library that is very optimized for Python. So wherever you have huge matrices and matrix operations, you can use NumPy for that. Matplotlib is one library to visualize our results. Say, for example, if you want to read an image and visualize it, you can do it with Matplotlib. If you want to plot some graphs, you can do it with Matplotlib. Jupyter is a platform which enables us to run Python interactively um, on a website or in your laptop, wherever. So Jupyter Notebooks is what Google provides in their Google Colab platform. So whenever you log into Google Colab, you get a Jupyter Notebook which is already loaded with a lot of packages, and it already has Python in it. So you can start coding right away. Okay, so at this point, I think we can maybe take a moment to think about some of the things that we already discussed. So we went through different classification kind of problems, regression kind of problems. We defined machine learning, deep learning, AI, representation learning. After all of this, we looked at what is explainable artificial intelligence and why XAI is important, especially for mission critical applications such as healthcare, self-driving cars. If people are using it in the army, AI in the army, you need to definitely understand why this AI is making a particular decision. So this field of science, the AI, is actually changing quite a lot of things, and I think personally AI revolution is going to sustain for quite a lot of time, and the only thing that I expect to change is the way we are looking at AI problems. So remember the system 1 and system 2 we discussed, that um, we might see a lot of changes from the way we are approaching AI problems, and we might include a lot more of this cognitive neuroscience kind of ideas into artificial intelligence or deep learning. Okay, so let's see some of the questions that I got from students before the start of the webinar. So quite a lot of questions were regarding robotics, so I just picked some of them. And some people asked what is the difference between data scientist and data analyst, etc., and the importance of AI in power systems, smart grids, and one common term was job opportunity. So I put it there as well. The first one, we will come back to it, the AI disruption, but we will look at the second point and we will scale it up a little. We will see how relevant AI is for a lot of things, not only robotics and self-driving car. I think we already mentioned how relevant AI is for robotics and self-driving car. For self-driving car specifically, you need AI to understand which lane you are going, how fast you are going, what kind of decision you are going to make, how many cars are there around it, what is the path that I should go, the shortest path to reach my destination automatically. Quite a lot of stuff. So while talking to some deep learning engineers working on self-driving cars, I was told that there are 10 to 20 different AI algorithms working on a self-driving car real time. At the same time, 10 or 20 different AI algorithms are making decisions to guide the car in the right direction and make the stops and do certain stuff, and you have to do all of this data analysis and AI decision making at very less latency. You have to do it within milliseconds of latency. So that is the complexity of all of this, and AI algorithms are driving this. Okay, self-driving cars and stuff. Robotics, I really want you guys to look at Boston Dynamics. So if you go to YouTube and you search for Boston Dynamics, you will see that okay, let me try to pull it up for you so you guys can see it. Okay, look at here. So these robots that you see here, these are trained to do a specific task. Okay, and these robots are now pulling a truck. Another robot that you see here is actually start learning to walk in a dynamic environment with a lot of rocks and stuff. This one is actually start learning to walk. This is the early days of Boston Dynamics. Okay, this is learning to walk in an icy road or something. Okay, just see their progress. Okay, balancing in one leg, etc., climbing a rough terrain. I'll skip some more, and now you can see here where we are with Boston Dynamics and all of these stuff. See this robot. Yeah, this robot actually started to um, open the door, and this guy is trying to resist it from doing it, but this robot just opened the door and put one leg to make sure the door doesn't close. This is super cool. This is 10,000% cool. All right, so I get carried away quite a lot. All right, so let's look at the second point, how relevant is AI, not just in robotics and self-driving cars, but some of the applications in the different walks of life. So when we look at it, we might be using AI in a variety of different use cases, variety of places, which we might not know right now. So in banking, we are already using AI to find anomalies in credit card transactions, AI based chatbots to talk with you, excuse me, and excuse me, loan acceptance decisions. Some of the decisions are made by AI algorithms right now. So in banking, I think I've heard that HDFC Bank, they are using AI for anomaly and credit card fraud detection, if I'm not making a mistake. So some of our banks are already using AI to do quite a lot of stuff. In transportation, I don't have to tell you this. You already know that many different players like Uber, Lyft, Google, Apple, Tesla, so many of these players are actually using AI to do several stuff. In Uber and Lyft, the ride sharing apps especially, they use AI to optimize their route, minimize the wait times as customers that we have when we are trying to find a ride, etc. In Google Maps, the algorithm behind it, it optimizes the route that we have based on the traffic, etc., and that is AI based. For Tesla cars, the vision, the way the cameras look at the things in front of it, in front of the car, how the AI algorithms understand how many cars are there, how many lanes are there, etc. The planning from going from point A to point B in the map, using all of these, and in an autonomous way, AI is used in that entire pipeline of autonomous vehicles. For email, if you open Gmail, probably your spam detection and your email categorization as primary, social, etc., that is done by AI algorithms in marketing and social media. You know, for example, in your Facebook, if you um, upload a photo or something, you will get suggestions to tag some certain people. That is all using AI face detection, etc. If you are trying to post an image somewhere, and if you get hashtag prediction, especially in LinkedIn, etc., you will perhaps get emoji suggestions. All of these might be using AI, and some of these are definitely using AI itself. In an entertainment, your YouTube video recommendations and your Netflix movie recommendations, these are AI based. So uh, they basically understand as individual users how our watching patterns are, and then they suggest based on quite a lot of historical data that they have. In healthcare, automatic disease prediction, progression analysis, etc., is actually using AI algorithms. For example, the one that I mentioned, age-related macular degeneration study that I did, and also if you have um, multiple years of data, a patient comes into hospital for 5 years, every year we have specific data for it, and we can use that data to understand how the person will be in the sixth year. So that is progression analysis. So AI can be used in that domain as well. Okay. So let's look at some of the job opportunities to answer some of the questions the students raised. So the the first answer that I give everyone is that it depends on what you want to become. And generally, there are three different categories of what a machine learning enthusiast can become. It can be either a data analyst post, a data scientist post, or an AI developer post. These are generally, I'm not saying that these are only three, but these are generally the three categories in which we can apply for jobs as a machine learning engineer. An analyst or a data analyst um, generates high level reports and analysis of data. So you get quite a lot of data from maybe some sensors that are collecting for data from your smart grid, etc. You will collect this data, you will clean the data, you will store the data maybe in some kind of um, tables or databases, etc. And you generate some kind of high level reports based on this data, do some preliminary kind of processing on this data, try to understand what the data is, etc. So more of the focus is towards generating the data, handling the data, making sure that the data is safe and secure. Some of the null fields in the data, perhaps, that those are accounted for, etc. That's the role of the data analyst. You probably need math, CS, statistics, and some kind of an economics background uh, to be a good data analyst. And definitely, all of these can be improved by learning and practice. Like all of these, like analyst or scientist or AI developer, whatever. Especially, we are talking about a webinar where we are trying to improve our learning of AI or understanding of AI right now. So all of these can be improved by learning and practice. So data scientist, the next level, he receives a lot of data from the analyst and some of the initial reports from the analyst, and he tries to identify some of the trends and opportunities in this data. How can I use this data to increase the revenue of my company? How can I use this data to generate more ad revenue? How can I use this data to get more user engagement in my product? Those kind of questions where there is some more of this concept of turning data to gold involved, which is basically means making some kind of favorable outcomes for the company. That is the role of data scientist. So at just hearing this explanation, you will understand that this is a little bit more involved process where you work with the higher management, try to understand what are the goals for the team, goals for the company itself, and then you try to understand some kind of predictive modeling or some kind of machine learning algorithms to improve some of the pipeline that you already have, or some of the future timeline, what will be the state of the company, moving forward, etc. Those kind of understanding. Or if you have certain products that you have in your mind, or the company is already developing, how can I improve as a data scientist with the data and the report that the data analyst give me? How can I improve all of this pipeline for my company? So that might be the role of the data scientist. For this, you need to have a math, a CS background, a statistic background, and also you should be a very good critical thinker and a problem solver. You need to have some kind of reasoning and logic embedded in your every thoughts. Now, since you are thinking that way, you can always get better at providing insights and trying to find some kind of patterns within the data. Okay. AI developer is someone who works with both the analyst and the data scientist, and he is the guy who usually facilitate a lot of this model building, API design, software engineering design, those kind of stuff, for that particular data analyst and scientist. Say for example, you have a machine learning model and you want to serve it in a website. This AI developer should have some kind of understanding about AI, but not quite. He will be more towards the CS side of it, the website building or the UX UI design, those kind of stuff. But he will definitely have some kind of AI knowledge to understand, hey, what is going on, what is not working, etc. He might be the guy who is writing some of the test, software test for the data scientist. And usually you should know the full stack of software design, and there will be definitely a lot more emphasis in the programming side of things and very less to the AI side of things. For me personally, I've seen that LinkedIn is a very good source of job postings, and um, you'll probably get a good understanding of the current scenario where your particular job likings are. uh, One of the things that I want to suggest, however, for people in India is to look at that website that I've provided here, indiaai.in. This is actually from the government of India and was opened quite recently. And I'm pretty sure this will give you an idea of what to expect in a place like India, with quite a lot of dynamic changes that is happening in the field of AI. Okay. So going back to one of the questions about AI disruption, we see that this is quite a hard question to answer, because I would say the disruption caused by AI, it depends on um, where you are in the globe and what kind of an economy do you have. You know, especially I want to actually encourage you to look at one of the discussion paper that you can see here. This is by Niti Ayog, and this is titled The National Strategy for Artificial Intelligence, and this is by the government of India. So in this discussion paper, government of India actually mentions that the focus of AI for India primarily is in healthcare, agriculture, education, smart cities and infrastructure, and also smart mobility and transportation. Okay. So the five vectors. And when you think about it, healthcare, Google is already working with quite a lot of hospitals in India to develop some of these AI algorithms. In agriculture, you can maybe perhaps using drones or something, you can understand the amount of cultivatable land. um, you can understand if the land needs watering, um, whether there are pests in your field, etc. In education, perhaps you can understand how you can improve your improve the education that you are providing to your student based on a variety of things. You can even go as far as to see how the students facial muscles are moving, and um, understand the attention that the student has using AI. In smart cities and infrastructure, we already mentioned it quite a lot of times. We have so much influence of AI in this particular field. In smart mobility and transportation, we also touched on this quite frequently. We have so much happening in this field, and I'm pretty sure there will be autonomous auto rickshaws and cars, etc., that will be in India pretty soon. But the problem with India is that, especially for smart mobility and transportation, we need to have better roads for better vehicles. So I don't know how much reach this will have in the initial, phases. And since we are talking about disruption, so I'm I'm um, so if someone asks me this particular question on where the AI disruption, what will I just lose my job because of AI? I would like to emphasize that these are five vectors that government of India mentioned that they are going to spend their time in, and if they are going to do what they mentioned in this discussion paper, I would definitely focus on these five points as um, places where we can actually see some positive and negative effects of AI moving forward. Now, I would like to talk about the interdisciplinary nature of AI. Take my research for example. I'm a PhD student in the electrical engineering department at UT San Antonio, and I'm working primarily with medical data and building explainable AI algorithms on top of it to basically understand diseases. So my research is to work with scientists and doctors, healthcare practitioners, work with them very closely, try to understand what they want from us, build machine learning models on top of their data after doing the data analysis, data processing, and show them the results. Um, and if we do a good job on increasing the accuracy of the models, that is so good. But my job as an machine learning, scientist is to show the results, so good results, and also show why this particular AI model is making these decisions. So now when we can back up our AI decisions, healthcare practitioners are very happy because now they have a way to validate these decisions made by an AI. If you look at the figure that you see below on the lower side of the slide, that is a self-driving car system architecture, and you can see that there are numerous sensors being used to stream in data. You have perception and scene understanding block. You have behavior and motion planning block. We have vehicle control and actuation block. You have the system management block, and you can definitely see how various electronic engineers are required for the sensors and sensor fusion, etc. Electrical engineers are required for a lot of the electrical components and bringing them together. Behavior and motion planning systems and vehicle control, a lot of mechanical engineering based system engineers required. This level of projects which actually make significant impact on human lives, I would say that this is possible only using interdisciplinary research. And I definitely encourage you guys to collaborate more, talk to your peers more, talk to the other departments more, talk to the professors in other departments more, or talk to your professors and try to engage with the other communities and try to create some kind of a cohesive or very engaging interdisciplinary research group within the campus. Once we actually do this, we will see that there are so many things common in all of our fields, and there are so many things that we can do to enhance the other field from us. Okay. So once we do this, I think definitely we'll see a lot more research coming in and a lot more collaboration happening. That'll be very awesome to see. Yeah. So the key takeaways from this session is that AI is really good at doing certain tasks. However, they are still struggling to find a general AI model. So the system too, I think that is a little far ahead. A lot of people are actually spending so much time on this specific topic right now. Explaining the predictions of an AI algorithm is very important for mission critical tasks such as healthcare. You need to know what the AI is actually doing, yeah, so that you can improve the trust, reliability, transparency of these AI algorithms. Excuse me. So, math, statistics, and probability, along with control systems, network theory, signals, and system knowledge, is very beneficial for you to start AI for the power systems or the electrical engineering and smart grid domain. For me personally, I don't benefit quite a lot from the network theory or the power system domain. Um, because I'm focused more on the computer vision and medical domain right now. But definitely for someone who is trying to focus more on the um, smart grid side of things, I think that'll be a very good knowledge. Programming knowledge required, but to what level depends on what do you want to do with AI. So if you want to be an AI analyst, scientist, or just an AI developer, the programming knowledge required will be definitely different. AI is already applied on a lot of venues that we might be using it and we don't know yet. For example, in our emails, email categorization, spam detection, in our banking for our credit card fraud detection, etc. AI disruption, it basically depends on who you ask and where you live. We mentioned five different vectors of focus that India is looking at. And also the last one, interdisciplinary research is key, and we should definitely collaborate more. Okay. And these are some of the things that we can expect from the coming sessions. Here, the Python 101 course that I mentioned will focus on basic programming syntaxes and a high level introduction to Python. So you can join me definitely on another date. I will definitely post it in my social media once I get some time to do it. Uh, Hopefully, it'll be towards the end of June. So, so what we will do is to go through some of the high level Python syntaxes. We will probably try to code some algorithms in Python, some basic data structures, etc. Try to read some data, write some data, etc. Hopefully, we'll do it with some electrical engineering data sets. Let's see. So the AI course, AI 101, that will focus on building some AI algorithms in Python, and we will definitely try to do some machine learning on some kind of electrical engineering data set. I don't know it yet. Might be some data collected from smart grids or something. We will go through some of the machine learning algorithms, such as linear regression, logistic regression, decision trees. If we get enough time, we will go through neural networks, and I will move some of the advanced topics for the future because uh, I don't think we will have enough time in this 2 hour time frame to go through all of this. And one thing to note is that copy pasting code from the internet is easy, but building the fundamentals and understanding the concepts is very hard. So we won't be just going to CNN, convolution neural networks for computer vision and training some classifier to understand cat versus dog. We won't be probably doing that. But I want to actually touch base on all of these algorithms. During some of these sessions. So we will definitely look into some of them, but I don't think we'll be going too deep into these. Okay, that is it. And thank you so much, guys. I really appreciate you. I want to take some time to thank my professors at Cochin University of Science and Technology, QSAT, for constantly inspiring me. My fellow alumni members, A2E3 and ESA, the Alumni Associations of Electrical and Electronic Engineering of Cochin University, for this very wonderful opportunities. Um, as I mentioned before, this is a recording, a re-recording of a webinar that I gave on June 8th. So if you have any questions, please send it to me. You can find my LinkedIn on uh, the bottom side of the presentation, and also you can email me